Welcome to Drawsh Studio. Today we're going to learn how to draw a one-point perspective grid. Let's get started. Grids in perspective work off of the 45-degree principle. Because a box is made of 90-degree right angles, a line going from corner to corner would cut through at a 45-degree angle. Now let's imagine this square is on the ground and we are looking straight down on it. A box in one-point perspective is flat to the horizon, so if we extend the lines to meet it, it would look like this. The lines remain parallel because we are looking down, not in perspective. The line that goes from corner to corner meets the horizon at a 45-degree angle, at what we call the 45-degree vanishing point. Now, if we draw this square in one-point perspective, we see the lines vanish to the horizon. This means that the corners of the box are not truly 90 degrees, but represent a 90-degree angle in perspective. The line that goes through the corners of the box represent a 45-degree angle in perspective. Taking that line to the horizon would give us a 45-degree vanishing point, because the 45-degree principle remains the same when drawn in perspective. This 45-degree vanishing point will be what aids us in constructing our grid. Now let's make a simple one-point grid. Start with a horizon line. Then we draw a horizontal line at the bottom of the page representing the back of our grid. Place a vanishing point on the horizon and draw lines in perspective to the back of the grid. Decide the size of your box with another horizontal line. This represents the first tile of our grid, and we will use it to construct other tiles. Next, we draw a line through the corners of the tile to our horizon, which gives us the 45-degree vanishing point. We draw another 45-degree line back to the opposite corner of our tile. The point where the new 45-degree line crossed our perspective line would be the back corner of the next tile in our grid, so we can draw a horizontal line through it to create the tile. The new horizontal line crossed our perspective line on the other side, which gives us another corner we can draw a 45-degree line to. This pattern repeats back. Horizontal line on the right, 45-degree line on the left. Horizontal line on the right, 45-degree line on the left. Horizontal line on the right, 45-degree line on the left. Because of the 45-degree principle, each time a 45-degree line crosses a perspective line represents the corner of another tile, and we go as far back as we want the grid to be. Now, we have a center row of tiles, but none on the sides. Notice that our perspective lines cut through each of the intersections of the horizontal and 45-degree lines. This means that each time we see one of these intersections, we will draw a new perspective line through it. It doesn't matter which of these intersections you choose to draw the perspective lines through. If your grid is correct, the perspective line should connect them all together. Now we can remove the 45-degree construction lines to see our complete grid. There is a problem with this grid, however. When we constructed our initial tile, there was no way to know if it was a perfect square in perspective. We just eyeballed a shape, which might have been a rectangle in perspective. If you don't need total accuracy, the simple method is a fast and easy way to make a gridded ground plane. If you do want more accuracy in your grid, there are a few steps we need to add in the beginning to ensure that the first tile is an actual square in perspective. To make an accurate one-point grid, start with a horizon line across your paper. Then choose your single vanishing point. Remember, in one-point perspective, the vanishing point is in front of the viewer. We also need to decide where to place the station point. Since the station point is the distance the viewer is standing from the horizon, in one-point perspective, we can simply draw a line coming straight down from the vanishing point. We stop as far down as we like, but generally, the farther down the better. Because of the 45-degree principle, if we draw a 45-degree angle from our station point to the horizon, we will get a 45-degree vanishing point that is accurate to the viewer's perspective. Now, Draw a line near the bottom of the page to represent the bottom of the grid, and then mark an equal distance on either side of the station point to represent the width of our first grid tile. Then draw perspective lines from the corner of our tile to our vanishing point. A line from the bottom corner of our tile to the 45-degree vanishing point will cut through our perspective line, showing us where the back corner of the perfect square tile would be. From here, the method is the same as the simple grid. A 45-degree line needs to connect back through the opposite corner of the tile. This sets up the left-right rhythm of horizontal and 45-degree lines. As you move back, the lines will become closer together, making it a little more difficult to accurately place them. Then draw perspective lines where the horizontal and 45-degree lines intersect. And now we have a more accurate grid. Because our first tile was based off of the station point, instead of choosing it randomly like we did in the simple grid, we have a true square tile, meaning all four sides are the same relative size and perspective. Now we can associate a scale to the tile and know that any section on the grid would be the same scale, making it more accurate to measure from. Thank you for watching. Don't forget to go to Drawsh.com for more information on these topics and many more. If you want to see more videos like this, like, share, and subscribe, and I'll see you for the next one.